Central Florida 36 years ago has made it beyond the solar system. First human-made object has been racing through the cosmos for nearly 5 decades and sending back data that transformed our understanding of the solar system and beyond. But now, as this legendary spacecraft drifts farther into interstellar space, a strange, cryptic message has shaken scientists to their core. What could it mean, and should we be worried? NASA's program began as an ambitious quest to investigate the outer solar system at a time when planetary alignments offered a rare opportunity. In the 1970s, a unique arrangement of Jupiter, Saturn, Uranus, and Neptune allowed a spacecraft launched from Earth to catch gravity assists from each of these distant worlds in a single trek. This lineup, which only appears once every 176 years, sparked the idea of sending automated explorers out beyond Mars to see what our outer neighbors were really like. Project engineers worked for years designing 2 spacecraft that would be hardy enough to survive extreme temperatures, radiation belts, and intense solar storms at the far reaches of our solar system. Funding and timing were crucial since NASA officials knew that a window for this multi-planet tour would not come around again until well into the future. They finally settled on 2 spacecraft, which would be nearly identical but might follow slightly different routes depending on the data each gathered along the way and the discoveries they made at each planet. These spacecraft would be small buses about 1.5 feet in height and nearly 6 feet wide, sporting large high-gain dish antennas on top. The dish, 12 feet across, would be essential for sending data to Earth and receiving instructions. Also carried a boom for instruments that study magnetic fields, solar wind, and charged particles. Each spacecraft was equipped with cameras narrow-angle and wide-angle, to capture everything from big planetary portraits to detailed shots of cloud tops, ring systems, and cratered moons. Were scheduled to lift off from Cape Canaveral using Titan Centaur rockets. Contrary to the numbering, Voyager 2 actually blasted off first on August 20, 1977. Voyager 1 followed on September 5, 1977, on a slightly faster, more direct trajectory. Standing in the Florida heat, onlookers knew something extraordinary was happening. But most had no idea these spacecraft would still be operating almost half a century later. From the beginning, the mission goals were to explore Jupiter and Saturn in detail, take advantage of gravitational slingshots for speed boosts, and then, if everything held together, possibly continue to Uranus and Neptune. Even the most optimistic planners couldn't have fully predicted how well these probes would hold up. They were expected to last perhaps 5 years, maybe a bit more if all went well. Yet both would go on to exceed every expectation and become humanity's farthest emissaries, revealing countless wonders along the way. These spacecraft also carried something more personal, a symbolic tribute to Earth and its inhabitants in the form of the now legendary golden records. Before we get to that cultural time capsule, though, the Voyager twins had a whole series of planetary visits that brought back images and data no one had ever seen before. The most common confusion about the Voyager mission is why Voyager 2 launched first but ends up named 2. During final preparations, project managers realized Voyager 1 would take a shorter, faster route to Jupiter and Saturn. They already had names set, so they left them as they were. It's a coincidence that 1 ended up launching 2 weeks later than 2, but it soon caught up and scooted past its sibling on its way out to the gas giants. Though built almost identically, each Voyager had slight differences in their flight paths. Voyager 1 was set for a close encounter with Saturn's largest moon, Titan, an encounter that would change its path out of the plane of the solar system. By getting near Titan, the spacecraft would sacrifice a chance to visit Uranus and Neptune. But NASA wanted that up-close look because Titan showed hints of a thick atmosphere that might be the only one like it in the outer solar system. Voyager 2, on the other hand, had its own brilliant itinerary. If Voyager 2 successfully met the mission's primary objectives at Jupiter and Saturn, NASA scientists would try to extend operations so they could aim for Uranus and Neptune. This grand tour plan demanded that Voyager 2's instruments remain operational well beyond the expected 5-year lifetime. Once launched, Voyager 2 headed off southwest relative to Earth's orbital plane around the Sun, while Voyager 1 set a more northerly course just a bit later. Because of the differences in trajectory, each spacecraft offered different viewing angles and encountered the outer planets at different times. Early in the mission, NASA tested all the scientific instruments: cameras, spectrometers, ultraviolet and infrared magnetometers, plasma detectors, and cosmic ray detectors, making sure everything was ready for action. Within 2 years, Voyager 1 was well on its way to Jupiter, speeding along at about 35,000 miles per hour. Voyager 2, also traveling fast, moved on an optimized track for possible extended missions. Both carried radioisotope thermoelectric generators, RTGs, as power sources, converting heat from decaying plutonium into electricity. This power system was crucial since solar panels would be useless so far from the Sun. Each spacecraft had thrusters for small course corrections, sophisticated radio transmitters, and recorders to store data before beaming it back to Earth. Thus, although they had the same DNA, the two Voyagers were like siblings who took different roads on a family road trip, and that difference in routes would shape their discoveries, determine which planets they'd focus on, and eventually decide how they'd exit the solar system. By 1979, both Voyagers arrived at the largest planet in our solar system, Jupiter. Within months of each other, Jupiter offered the first big test of their capabilities, and the results were beyond anything mission planners had hoped. The wide-angle and narrow-angle cameras captured up-close images of Jupiter's swirling bands, the iconic Great Red Spot, and something that stunned astronomers everywhere: active volcanoes on Io, one of Jupiter's many moons. Before Voyager arrived, scientists expected Io to be a cratered, cold chunk of rock. To their amazement, Voyager 1 spotted giant volcanic plumes erupting from its surface. These eruptions ejected sulfur dioxide, and other materials that gave Io's surface bizarre yellowish-orange and blackish hues. It was the first time in human history that active volcanoes were found on a celestial body outside Earth. The surprises didn't end there. The spacecraft discovered Jupiter's faint ring system, something that wasn't expected in an obvious way. Saturn was known to have rings, but Jupiter's ghostly rings were a new revelation, indicating that ring systems might be more common around gas giants than astronomers thought. The probes also flew by Europa, which showed an icy crust with mysterious dark lines crisscrossing its surface. Later research, including that spurred by these initial Voyager observations, led to the hypothesis that Europa may hide a liquid ocean beneath that ice, raising the possibility of extraterrestrial life. Voyager 1 came closest to Jupiter in early March 1979. It gathered data on Jupiter's powerful magnetic field and the intense radiation environment around the planet. The spacecraft measured lightning in the planet's swirling clouds and found that Jupiter's magnetosphere is enormous, almost unbelievably big, stretching millions of miles. This environment was so harsh that it caused occasional glitches in electronic components on the spacecraft, but both probes kept operating. Voyager 2 followed up that summer, providing further images of Jupiter's swirling storms, measuring the temperature differences across the atmosphere, and confirming volcanic activity on Io. It also helped build a better picture of the newly observed ring system. With both craft effectively doubling the data, planetary scientists assembled a surprisingly complete picture of Jupiter's structure, weather, and moons. They also discovered new Jovian satellites, proving that Jupiter's family of moons was bigger and more diverse than expected. After passing Jupiter, Voyager 1 was on a path to Saturn, while Voyager 2 continued on the same overall route. Each craft used Jupiter's immense gravity to slingshot outward at higher speed, saving precious fuel. With the Jupiter leg complete, the stage was set for the next phase, a close-up encounter with Saturn's glorious rings. Saturn, with its spectacular rings, had dazzled astronomers for centuries through telescopes on Earth. But until Voyager got there, no one truly knew what those rings were made of or how many of them existed. In late 1980, Voyager 1 arrived at Saturn and immediately began sending back breathtaking images. From a distance, the rings looked like broad, bright bands around the planet. Up close, they revealed countless individual icy chunks and finely divided rin.